Hello class, in this video we cover section 11.5, probability with the fundamental counting principle, permutations and combinations. The examples of this section are about finding probability, most of times classical probabilities, but the process of finding those probabilities need to use the concepts of counting, fundamental counting principle, permutations, and combinations. So let's look at the first example. 7 performers A, B, C, D, E, F, and G are to appear in a fundraiser. The order of a performance is determined by random selection. Find the probability. So we are going to find the probability for the following ABCD 4 events. All right. So let's see what kind of model do we have here. The experiment involved can be seen as randomly select the arrangement of the 7 performers, right? Yeah. So how many outcomes, possible outcomes from the experiment? What's the sample space? We should have 7 factorial, that many possible outcomes, because we have a 7 factorial or P77, that many ordered arrangements for the 7 performers. And that's the experiment and the sample space. So obviously this is a classical model or theoretical model. Under such model, we're going to find part A, the probability that they will perform in the following order. Okay, so let's do this. Let A, so I'm supposed to write let A be the event that the 7 performers will perform in the following order, or following order, C, E, E, A, G, F, E. Just take some time to write it down. Basically use A to represent the event in part A. Then P of A, under such a theoretical probability model, can be found by using a fraction, right? By using a fraction. The numerator would be 1. Denominator would be 7 factorial. Let me explain. Denominator is the total number of possible outcomes of this experiment, right? 7 performers are to appear in a fundraiser. The order of performance is determined by random selection. So in total, we have 7 factorial, that many ways to arrange the performers. Among those outcomes, there's only one outcome favor event A occurring. So the probability is 1 divided by 7 factorial. Okay, we are going to use the calculator to find the result. You should do the same thing right now. I'm going to use 1 to divide it by 7 factorial. In the previous video, I already showed you how do we use TI-84 calculator to find permutation, factorial, and a combination. The result I got is 1 point. Let me show you what does this mean if you ever see something like this in a calculator. So the calculator will give you this result: 1.98412699884, but not done yet. E to the power of 94. What does this mean? Since the calculator has a limited space, right? If you see something like that, that means that we are going to move the decimal point 4 places to the left. Yeah, this basically means multiply by 10 to the power of -4. So our result is supposed to be a decimal with the decimal point in the given decimal to the left 4 times. So we have 0.0001984126. Let's round it to 7. Depends on how does the question require us to round the result. Yeah, as you can see, the probability is very small, right? Yeah, the probability is very small, 0.000198. Maybe you can round it to 0.00. If we keep 4 decimal places, round it to the 0.0002. Again, depends on how does the question require us to round the result. Continually paying attention to the instruction in the parentheses when you work on the assignments in this chapter. All right, does that make sense? This is a theoretical model. Sample space contains 7 factorial, that many ordered arrangements, outcomes. And event A only has one, yeah, a certain order, so only one outcome. This is an outcome, one of the 7 factorial, that many, one of the 7 factorial outcomes. So the probability is 1 over 7 factorial, or 1 over P77. Part B, and we consider the event B. Yeah, let B be the event that B will perform first. Then P of B. Remember, this is under the same theoretical model, so the denominator would be always the same, right? The denominator would be always the same. What about the numerator? The numerator would be how many outcomes favor event B. How many outcomes favor the result that D performed first. Okay, so the result is 6 factorial divided by 7 factorial. Denominator is the same, right? Denominator is the same, 7 factorial, total number of outcomes in the sample space. Numerator is 6 factorial because if we consider, you know, this is how do I like to do permutation. 7 performers, so we have 7 slots, time slots, right? 1, 2, 3, 4, 5, 6, 7. And even B has D performed first, so D is already here. There's no, so there's only one way. There's only one way to arrange D, the first place. And for the next 6, 1, 2, 3, 4, 5, 6, right? Yeah, we have 6 factorial. We have that many different ways to arrange the rest 6 performers. So 1 times 6 factorial is 6 factorial. Remember, 7 factorial is 7 times 6 times 5 times 4 times 3 times 2 times 1. So 7 factorial is 7 times 6 factorial. And numerator has 6 factorial as a factor. Denominator has 6 factorial as factor. So once you cancel them, the answer is 1 over 7. Yeah, I would leave the result as a fraction. Again, depends on when you work on assignments in MATLAB Math, just look at the instructions. Part C, E will perform 6 and B will perform last. Okay, so whenever you use a letter to refer to a certain event, you should make it clear the beginning of your solution. Let C be the event that E will perform the 6 and B will perform the last. The last means the 7th, right? 7th. Okay, then P of C, again, same classical model. Denominator always 7 factorial. That's the total number of possible outcomes. And we focus on the numerator. Yeah, numerator. Let me type the result and I will explain. All right. Yeah, you can also think about, yeah, what's the numerator is going to be? The numerator is going to be 5 factorial divided by 7 factorial. Let me explain. Denominator is 7 factorial. That's understandable, right? Total number of outcomes. 1, 2, 3, 4, 5, 6, 7. Okay. And to make event C occur, the following conditions has to be satisfied, or we can make event C occur by doing the following 3 things. What 3 things? The first thing, put E in here, 6 slot, the 6th time slot, and put a B in here, the last slot, right? So to arrange E, we have 1 option. To arrange B, we have 1 option, right? And that's the second step. The third step, we still have 1, 2, 3, 4, 5 slots and 5 performers, and that gives us a 5 factorial, right? So fundamental counting principle, you just multiply them all together. So we should have 5 factorial, not many different ways to make event C happen. In other words, among the 7 factorial total 7 factorial possible outcomes, there are 5 factorial. That many outcomes favor event C occurring. That's the reason numerator is 5 factorial. Okay? Denominator is 7 times 6 times 5 factorial. You should be familiar with the 5 factorial if you have done the homework. And the numerator denominator has a common factor, 5 factorial, so we can cancel them. And numerator is 1, denominator is 42. I'll leave the result as a simplified fraction, 1 over 42. Part D, F or G will be performed first. Okay, so let F be the event that F or G will perform first. Then P of, let's change it line, P of B, oops, P of, oh no, my bad. Let D, part D, let D, this letter D, be the event that F or G will perform first. Then P of D, equals what? Let me write the result first, okay? Let me type the result first. Remember, denominator is still 7 factorial. Numerator, let me think. F or G will perform the first. So it's going to be 2 multiplied by 6 factorial divided by 7 factorial. The 2, I meant the 2 be the numerator. 2 is here. Let me fix this part. And then let me explain, all right? We understand the denominator is 7 factorial. Yeah, let's focus on understanding the numerator. Draw those boxes, 1, 2, 3, 4, 5, 6, 7. 7 performers, right? Yeah, we have 7 time slots to arrange them. To make event D happen, to make event D occur, we're going to follow the following 2 steps. The first step, we're going to arrange a person in the first place. Remember, event D is the result that F or G will perform first. So we have how many options to arrange the first slot? We have 2 options, right? Yeah, because we can put F here, or we can put G here. So we have 2 options to do the first slot. And for the rest, 1, 2, 3, 4, 5, 6 slots, do we have any specific condition to be set to need to satisfy? No, we don't. So the second step would be put the rest 6 performers in the 6 time slots. So 6 factorial. Yeah, use the fundamental counting principle. Make your solution clear. I believe some of you have taken probability classes in previous math classes, but I also believe some of you, most of you, the way you process probability maybe is intuitive. So the purpose of this class, the goal I want to reach is you can compute the probability not just by instinct. You can compute the value of the probability by thinking clearly. Why? Because it's a classical model. Yeah, that's the reason denominator is 7 factorial, the total number of possible outcomes. Yeah, and numerator, yeah, how do we get a numerator as a 2 times 6 factorial? Because in order to make event D happen, we have to do the following two things, right? We can use the fundamental counting principle to explain. In the first slot, we have 2 options. The rest 6 slots, we have 6 factorial that many options. So instead of intuitive, you think clearly, you have a logic, you have a reasoning. Let's compute the value. So 6 factorial, denominator 7 factorial can be written as 7 times 6 factorial. Numerator is 2 times 6 factorial. And 6 factorial cancel 6 factorial. We have 2 over 7. And that's the result. Okay, let's go to example 2. A political discussion group consists of 5 Democrats and 6 Republicans. I apologize for my broken device. Yeah, 4 people are selected to attend a conference. So when you see something like that, you know this is going to be a combination. Yeah, earlier, performers, arrangement, that definitely is a permutation. But here, definitely is a combination. So our task here, or our experiment here, is to select 4 from, what is our task? Select how many people? 4 people to form a subgroup to attend the meeting, right? So the order of the 4 people in the subgroup doesn't matter, it's a combination. From how many people in total? Discussion group 5, 6, 11, right? Yeah. So that would be the total number of ways to complete this task. You can also see the task as an experiment, right? Yeah. One of those outcomes will occur every time you select, process the task. And we are going to find the following 3 probabilities. Part A, in how many ways can 4 people be selected from this group of 11? In how many ways can 4 people be selected from this group of 11? Okay, we just actually answered already. C for 11, right? Let's use a calculator to find the result. I'm using my TI-84 calculator. I enter 11 first and then go to math, probability, number 3, NCR, and enter 4, and then confirm 330. Part B, in how many ways can 4 Republicans be selected from the 6 Republicans? In how many ways can 4 Republicans be selected from the 6 Republicans? So that's a simple combination. C64. Yes, the number of combinations of 6 items taken 4 at one time, right? So C64. 4 Republicans be selected from the 6 Republicans. And use the calculator to find the result. Enter 6, go to math, probability, NCR, and then enter 4, 15. I got a 15. So yeah, that's correct. 6 times 5 divided by 2. Part C, find the probability. So the first 2 parts are not finding probability. the first two parts actually is to get us ready for part C. Part C is to find the probability that the selected group will consist of all Republicans. I'm going to do the same thing again. You don't have to, since it's probably multiple choice question, but as a free response question, the formal way to write a solution is you have to specify. If you use the letter E to represent an event, you have to specify what is E represent. Let E be the event that the selected group are all Republicans. Also, when you write down what does E represent, it's actually help you to understand the problem better. Then P of E. This is also classical, right? It's also classical. The sample space contains the C11,4, that many equally probable outcomes. Is also classical. Any probability involves permutation, combination, they must be a classical model. And in a classical model, we need to find the two numbers. One go to the numerator, one go to the denominator to find the probability. So the numerator is going to be, the denominator is going to be, all right? Yeah, so the denominator is C11,4, the total number of possible outcomes. Part A actually is prepare us for the denominator. And the numerator is 15, C64. Among the 330 outcomes, possible outcomes, there are 15 outcomes favor even E occurring. All the 4 people are Republicans. It's nothing to do with the Democrats. So 15 over 330. You will see many problems in MATLAB math have the same pattern. Yeah, part A get you ready for the denominator, part B get you ready for the numerator, and then part C asks you for the probability, right? So if we simplify this fraction 22, because 15 times 22 gives us 330. Yeah. So the simplified probability would be 1 over 22. Number 3. A committee of 5 people is to be performed from 6 lawyers and 7 teachers. Consider the task here is a combination problem, okay? The 5 people in the subgroup, the committee is a subgroup. You are going to select from the, how many people in total? 6 lawyers, 7 teachers, 6 plus 7, 13. 13 people in total. Yeah, you are going to select a 5. You are going to select a subgroup with size 5 to for the committee, and the order of the 5 people in the committee doesn't matter. It doesn't say who is going to be the president or vice president. It doesn't have any of those at all. So this is a combination problem. Find the probability for the following 2. Okay, so the sample space should contain C 13,5. Okay, yeah. Our task here, our experiment here is to randomly select 5 people from the in total 13 people to form a subgroup. And that's going to be the denominator. Okay. Yeah, let me rewrite it better. Denominator is going to be C 13,5 or C513. If you might see this when you look at other books, same thing, or you even see this. It's just different notation. Our book used the notation that very consistent with the calculator. Okay, part A, you can do this. Let A be the event that committee, select the committee, all lawyers are all lawyers. Okay. Then P of A, this is a classical model. We're going to find the two numbers. Denominator, we already know the denominator. What about the numerator? All the 5 people are lawyers, right? All the 5 people are lawyers. Okay, so the numerator is supposed to be, let me try this, 6. You know what? I'm not going to use this function. I'm going to handwrite it. P of A is going to be this. Denominator is going to be C513, right? Yeah, the 5 people randomly selected from the 13 people. Numerator is going to be what? All the people are lawyer. How many lawyers? 6 lawyers. C65 or C56. That many outcomes favor A occurring. Where we have 656, that many ways to make the result A happen. Just select the 5 lawyers from the 6 lawyers, form a committee, right? Okay, let's calculate. C65 the same with C61, so it's just a 6. Denominator. Let's see, what do we have? 13 math, probability, CNR, 5. Denominator is a 1287. 1287 is not divisible by 6, but divisible by 3. So if we divide each numerator, both denominator by 3, let's simplify. Then we would have 2 here, and then we would have 429 in the denominator. Okay? Yeah, let me double check my result. Yeah, that's correct. Or if you need to express the result as decimal, just do so. Or a simplified fraction. Part B, none are lawyers. Let B be the event that the selected committee are all, so none are lawyers. That means that all the people in the committee are going to be what? Teachers, right? Then P of B, classical model, 2 numbers, numerator, denominator. Denominator C513 combination, total number outcomes. Numerator, all the selected committee, all the 5 people in the committee are teachers, right? How many teachers in total? 7. So C75. Okay. By the way, if you pay attention to my video, I want to show you that you are able to simplify a fraction by using TI-84 calculator. That probably saved you a lot of energy and mistakes. Let's take this as an example, okay? So firstly, let's find out what is a C75. 7, 5, 21. Denominator, we already got denominators 1,287, right? Okay, so let me show you how do you simplify the fraction by using TI-84 calculator. Paying attention, you enter 21 divided by 1287, right? And then the calculator normally will give you a decimal. Depends on the requirement. If you need a decimal, then you keep a decimal. If the problem requires you to give the answer in a simplified fraction, this is what you can do. You go to Math, FRAC, do you see that? FRAC, fraction, and enter. They will give you a simplified. Let me do it again. 21 divided by 1287. And math fraction will give you a simplified fraction is 7 over 429. Okay, let me say that again. If you didn't watch videos and you do not know this trick, you might make a mistake when you simplify the fraction. So once you enter this in the calculator, you enter math, and you'll see the number 1 is a fraction, FRAC, and you just enter, and the calculator will provide you with the simplified fraction. Very efficient. Okay, last problem, number 4. If you are dealt 4 cards from a shuffled deck of 52 cards, find the probability that all 4 are hearts. This is about the combination, okay? The task here or experiment here is to deal 4 cards from 52. The order of the 4 cards doesn't matter. All it matters is to get the 4 cards as a subgroup. So the denominator of the probability we are looking for is going to be that number. That's going to be the number of outcomes in the sample space. Find the probability that all 4 are hearts. So that's going to be the denominator. Numerator is going to be all the 4 cards are hearts. How many hearts do we have? In previous video, I already emphasized, even in real life, you have never gotten a chance to use any poker. That will not be an excuse that you don't know how to do the problem. Like I don't know poker at all. How do I do the problem? You figure it out. All right. Each deck has 4 suits. The 4 suits are hearts, clubs, diamonds, and spades. So the event is all the 4 cards you are dealt are hearts. So we have 13 hearts here. So C for 13. Let's do the calculation. 13 math, probability, NCR, 4. Numerator is 715. And then we do the denominator. 52 math, probability, NCR, 4 is a very large number. 270725. And definitely this fraction is not simplified because the last digit of both numerator and denominator are 5. So at least they have a common factor of 5. Yeah, you can manually simplify. That's actually what I recommend you to do. That's a purpose that you need to take the algebra before taking this class. But to make your job easier, you can use the trick that I just give you. 715 divided by 270725, and then go to math, fraction, enter. 11 over 4,165. All right. So that would be the last problem, I believe. Yes. So those are good examples, pretty similar with the problems you are going to encounter in your assignments. So just to practice, again, find the reasoning, why, what kind of model this is, why the denominator is that number. How do we find the numerator? By using fundamental counting principle, permutation, and combination concepts. All right, I'll see you in the next video. If you have any questions, please feel free to email me. Bye-bye.